Applications of vectors to navigation. When sailing or flying, wind, or possibly current with sailing, alters your direction. If you know which direction you need to head in, then you have to alter your directions to compensate. True course T is where you are actually heading or where you want to head. The current C is what the wind or the sea are doing naturally. And the heading H is the direction you are travelling before the wind or sea changes you. Overall, T is equal to H plus C. So your true heading, where you want to go, is equal to the heading you set plus the current. This will help you to find where you will end up or decide what course to chart to end up in the right destination. A plane is travelling at 500 kilometers per hour and headed on a bearing of 120 degrees. So this is true. There is an air current of 50 kilometers per hour coming from a bearing of 225 degrees. What is the actual speed of the plane and in which direction is it headed? So let's start by looking at true. If this direction is north, we know it's going on a bearing of 120 degrees, so that's down here, and this is 500. So that's 90 degrees, that would be 30 degrees. So across here we're going to have 500 cos 30 degrees, and here we're going to have 500 sine 30 degrees, and note this is downwards. So we can say that true is equal to 500 cos 30 and negative 500 sine 30. Now let's look at the air current. So once again we're going to need a north. It's coming from a bearing of 225. So in other words, it's going in this direction here. So if this is 225, take away 180, this is 45. And then we can form a right-angled triangle, so it's going up and across. This angle here is also 45, since this is a right-angled triangle. And so C is going to be 50 cos 45 degrees and 50 sine 45 degrees. Now we know that true is equal to heading plus current. That means that heading is equal to true take away current. So that's 500 cos 30 negative 500 sine 30 take away 50 cos 45 50 sine 45. And calculating to two decimal places, that gives me 397.66 and negative 285.36. So that's going across and then down. So that this is 397.66 This is 285.36. This is a right angle, and this is our actual vector. And we're interested in the magnitude of that vector, which is the speed. And this angle will help us give the direction, because remember, north is just here, and this would be 90 degrees. So, using Pythagoras' theorem, we'll find that the speed is 489.5 kilometers per hour to 1 decimal place. Calculating the angle turns out to be 35.7 degrees. Add that to the 90, and that gives us a bearing of 125.7 degrees. We could have done this question by drawing a diagram and using the sine and cosine rules. Let's just look at that. So here's north, and we know that true is 500 on a bearing of 120. The wind is coming up in this direction, and this needs to be the resultant. So the actual heading would be down here, and then the wind brings us back to true. If we look at the wind, we know it came from a bearing of 225. So 225 is down here. And then that would be 45, this would be 90, so this angle here would be 45 degrees. Then if we form a little right angled triangle just here, we can see that this angle is 45. If we put a north line on here, these are co-interior angles, so this is 60. And so we've got a straight line down here with 60 and 45 already, meaning this angle here would be 75 degrees. We know that the magnitude of this wind is 50. So if we just draw that triangle out, because it's quite cluttered now, what we know is that this angle is 75, this length is 50, this length is 500, and we want to know the length of this side, and this angle here would help find the bearing. So we can then use the cosine rule, so v squared is 500 squared plus 50 squared, take away 2 times 500 times 50 times the cosine of 75 degrees. Work that out and square root, and we get the same answer, 489.5 kilometers per hour. And then we'll use the sine rule here, so sine theta over 50 would be equal to the sine of 75 over the answer we just found, and then we can solve that for theta, and we get 5.66 degrees, which we'd add on to the 120, giving the same bearing as we had before, which was 125.7 degrees. I think this method is harder. It's harder to draw the diagram in the first place, for a start, and then we're using sine and cosine rules. I'd rather do it by resolving. That's my personal choice. Mr. Cross is bringing his yacht back into its mooring. There is a current of 3 knots on a bearing of 215 degrees. He wants to travel at 8.5 knots on a bearing of 266 degrees. What speed and direction should he be steering the boat to make this possible? If you do this, or try to do this, by drawing a diagram and using the sine and cosine rules, you'll find it's very difficult to find any of the angles. What you'll end up with is some equations that you'll need to solve at this stage of your maths on your CAS. But it's quite easy to do this using components, so that's the way we're going to do it. So we know true. That's what he actually wants to do. So he wants to go at 8 knots on a bearing of 266. So that's down in this direction. And since this is 270, this would only be 4 degrees here. This needs to be 8.5. So true is going to be, remember that's going to be back this way and then down. So that's going to be negative 8.5 cos 4 degrees. And negative 8.5 sine 4 degrees. Now we have the current. So let's look at the current. So if this is north, the current is on a bearing of 215 degrees. So the current is in this sort of direction here. That's 180. So 215 gives us 35 degrees here. So that will be 55 degrees here. Still back and down. So the current will be, the current had a magnitude of 3. So that would be negative 3 cos 55 degrees and negative 3 sine 55 degrees. Now, true is equal to heading plus current. So heading is equal to true take away current. So that's going to be negative 8.5 cos 4, negative 8.5 sine 4, take away negative 3 cos 55, negative 3 sine 55. And if we calculate that, then we get negative 6.76 and 1.86. So that's going to be back and up, like so. So this is 6.76 and this is 1.86. And the third side of that will be the actual heading. So Pythagoras will find us the speed, and that turns out to be 7.0 in this case knots, correct to 1 decimal place. And then if we work out the angle there, it turns out to be 15.4 degrees. North is here, bearing is clockwise from north, and I know that 3/4 of the way round is 270, so 270 add the 15.4 gives us a bearing of 285.4 degrees. We're now in a position to do exercise 4.08 on page 143 and then do the chapter review.